One of the concepts that we learned before is how to express exponential functions in logarithmic form and vice versa. To do that, we use this formula. If y equals a to the x, then x is equal to log base a of y. Now let's take an example for each case. Let's start with the exponential function y is equal to 2 to the x minus 3, and let's convert it, let's write it in logarithmic form. First, we need to isolate the exponential part. So let's add 3 to both sides of the equation. So we will have y plus 3 is equal to 2 to the x plus 1. Once that's done, then you can now apply the formula. So it means that x plus 1 is equal to the log base 2 of y plus 3. That's the log form of y is equal to 2 to the x plus 1 minus 3. Now the other way, if we have the logarithmic equation y is equal to the log base 5 of x minus 1 plus 7, if we convert this to exponential form, first thing we need to do is to isolate the log component or the log part. In this case, we need to subtract 7 from both sides. So that's y minus 7 is equal to the log base 5 of x minus 1. Then we use the formula. So it means that x minus 1 is equal to 5 to the power of y minus 7. The reason I'm bringing this up is because we will need this concept for today's topic, which is finding the inverse function of an exponential function and a logarithmic function. Now recall that not all functions have inverse functions, but for exponential and logarithmic functions, the inverse functions do exist. So let's have a look. Let's start with exponential functions and recall that an exponential function could either be, the graph could either be this increasing curve or this decreasing curve. Either way though, each of these curves pass the horizontal line test. So when you draw horizontal lines anywhere on each graph, there's only one intersection between the graph and the horizontal line. And that means that the inverse function exists. In other words, if a function is exponential, then, or if f of x is an exponential function, then f inverse of x exists. On the other hand, if you have a logarithmic function, recall that it could either be, the graph could either be this increasing curve or this decreasing curve. And again, either way, each of these functions pass the horizontal line test. So if we draw horizontal lines anywhere on the graph, there's only one intersection. And it means that the inverse function exists. In other words, if y equals f of x is a logarithmic function, then f inverse of x exists. So let's have a look at the exponential function f of x is equal to 2 to the x, whose graph is shown here. And let's graph the inverse function. If you remember, one way of graphing the inverse function of any function is to take a few points, interchange the coordinates, and plot them. So for this, let's take, for example, this point whose coordinates are 0, 1. If we interchange the coordinates, it will be 1, 0, and that would be this point. Let's take another point, say this one, which is 2, 4. If we interchange the coordinates, it's 4, 2, which is right here. Now, that will already give you an idea of how the inverse would look like. Actually, connect these points, the inverse would be here. So if that is f of x, so if that is f of x, then this is f inverse of x. And a more accurate version of the graph is this. And notice that again, if you get the inverse of a function, the function and the inverse function are mirror images of each other over the line y is equal to x. Notice though that the graph, if you look at the graph of the inverse function, it looks like the graph of a logarithmic function. Now actually, you will see later that the inverse function of an exponential function is a logarithmic function. So again, later we will see when we do this algebraically that the inverse of an exponential function is a logarithmic function. Now let's look at a log function. Let's say we have f of x is equal to the log base 3 of y. Let's draw the inverse function. Let's take a few points. Let's say this point, which is 1, 0. If we interchange 1, 0, it will be 0, 1, and it will be this point. Let's have this point, which is 3, 1. We interchange that, it will become 1, 3, which is right here. You can take many more points, but actually I'm already seeing the pattern here. The graph will look like this. So this is your y equals f inverse of x. And if you look at your f inverse of x, if you look at the graph, it actually looks like an exponential graph, an exponential curve. So this is a more accurate version of the graph, and later we will see, when we do this algebraically, we will see that the inverse of a logarithmic function is an exponential function. So let's now find the inverse function algebraically. And as with any other function, when we get the inverse function algebraically, one of the ways that we could do it is to use variable interchange. So let's take an example for each. For the first example here, we are going to get the inverse function of an exponential function, and later we will get the inverse function of a logarithmic function. Let's start with the first one. F of x is equal to 2 to the x minus 3. So the first step, let's write this as y is equal to 2 to the x minus 3. Then we do the variable interchange. Make y x and make x y. So that will be x is equal to 2 to the y minus 3. Then we solve for y. To solve for y here, we isolate y. First thing that we need to do is add 3 to both sides of the equation. So the result will be x plus 3 is equal to 2 to the y. So if we look at the resulting equation now, to solve for y here, we have to get the log. We have to write it in log form. So y is equal to the log base 2 of x plus 3, and that is your f inverse of x. And this is what I meant earlier when I said that the inverse of an exponential function is a logarithmic function. Okay, let's take the second example. F of x is equal to the log base 5 of x plus 1. So let's write this first as y equals the log base 5 of x plus 1. Then we do the variable interchange. Make y x and make x y. Then if we solve for y, we isolate y, we need to write this in exponential form. So first, we isolate the log part by subtracting 1 from both sides of the equation. The result will be x minus 1 is equal to the log base 5 of y. And again, to solve for y in this case, you have to get the exponential form. So y is equal to 5 to the x minus 1. And that is your f inverse of x. And that's what I meant when I said earlier that the inverse of a logarithmic function is an exponential function.